And good afternoon, everyone. Thanks for joining us. My name is Zach Allison with ATS. If you're unfamiliar, this is your very first ATS University, then thanks for joining us. ATS is essentially a software company, but my role and what we're covering today in all these ATS University focuses on our specialty, which is our ATS spec tool. So it's a product selection or product configuration software that helps engineers, interior designers, design build contractors, anyone making product selections stay up to date and current, keeps their projects accurate, and most importantly, delivers the product information in 10, 12 different formats that are designed and tailored to fit how you issue projects to market. So that's our goal. That's the really quick version. We are, a free platform for all those in the design community because we're paid for by our lovely manufacturers. And part of that service of, having the information on our spec tools that we also want to educate around the products that are available. So it's not just a software; it's more of an entire service that helps make sure that your specs stay up to date. You're knowing and understanding what to select, and then we've got experts and resources that can help answer any unique questions that might come up for a project or for an application. A big part of that is making sure that all of our lovely engineers and people that are specifying on the system stay up to date with all their CEU hours as well, and that's where our ATS University program comes in. So myself and my team across the country will do lunch and learns and set up these webinars as well, where we bring in our wonderful experts from our manufacturers. Like today, we've got Brian from the Charlotte Pipe team. I don't know. I'm relatively new to the piping world, so I can confidently say I've never met a man that knows more about the piping category. But hey, I've been able to pepper him with questions as we start to understand this product more and understand where and when it fits and how we can better make decisions and better lead our engineers in making decisions when it comes to this type of category. Because correct me if I'm wrong, Brian, this has been a bit of a wild west for many years. There's a lot of, we'll say, open specs out there.
Yeah, that's really true, Zach. Yeah. So we're hoping to tighten things up today.
Yeah. So with that all said, this is an accredited ASPE CEU. We're going to get a list over to Brian at the end of this so that he can take care of the registrations on his end. If you just need our basic ATS certificate of attendance, we send those out next day for every one of our sessions. And of course, if there's any questions or any help that you need along the way, you want to get some more information, feel free to reach out to me, Zach at atspec.com, ZACH at atspec.com. And we'll help get you started, help you understand the product in more detail, or help update your masters as needed. I'm going to be mostly keeping an eye on the Q&A field and raising questions along the way to Brian as we go through the presentation. So feel free to pop in your questions. Otherwise, thank you all for joining us. And most importantly, thank you, Brian, for joining us today.
Of course, thank you, Zach, and thanks everyone that's on the call today for giving us an hour of your time. I know that the presentation title may not be the sexiest in our industry, but it's an important topic, and it's one that is growing in popularity with engineers and their questions. But before I get started with the presentation, I just want to take just a second to introduce myself and tell you a little bit about Charlotte Pipe as well. So my name is Brian Connor. I'm the Director of Codes, Standards, and Field Technical Support for Charlotte Pipe. So I handle all of the codes and standards, all of the regulatory work for Charlotte Pipe in our industry or our areas of business. And then I also oversee a group of folks who call on engineers, specifying engineers, to make sure that we offer support for you in your day-to-day job. So that is our main function. I've been working now with Charlotte Pipe for 22 years, and Charlotte Pipe is, for those of you who do not know, a manufacturer that is based in Charlotte, North Carolina, We are a 125-year-old privately held fifth generation family owned company, which is kind of a mouthful, but we started in the piping business in 1901 with a foundry in Charlotte, North Carolina. And we've been manufacturing cast iron pipe and fittings since the inception in 1901. But we also manufacture plastic pipe and fittings in 7 manufacturing locations throughout the United States, where we manufacture ABS, PVC, and CPVC pipe and fittings. So we've been at it for quite some time, celebrating our 125th anniversary this year. And the fact that we manufacture both plastics and iron for us makes us feel like we're uniquely qualified to speak on some of the piping subjects that engineers are very interested in today. The topic of today's presentation is one of those where we've gotten more and more questions from the industry over the past, I'd say 5 or 6 years about aggressive applications and the use of cast iron. So without further ado, I'm going to share my screen and we'll jump right into the presentation. As I said, the title, Cast Iron Coatings for Aggressive DWV Applications. One might wonder how we got here from the inception of plumbing. Things change over the years, and we've all bore witness to that. No matter how long we've been in the plumbing industry, and we really have come a long way since the beginning. As man sort of civilized and population grew, it became evident that water needed to be diverted from its natural course bring into towns and villages for a number of different things: drinking, bathing, for sanitation, and for other needs. But not only diverting the water into these areas where people were living, but also taking the water that was used away. And there are some pretty well documented cases that have stood up through history of how civilizations have done that. Obviously, you see here an aqueduct, and that's one of the most readily available instances of where humans not only diverted water, but they brought in infrastructure that has stood the test of time and still stands today. The Romans maybe are most famous for this, but many civilizations had aqueducts where they diverted water into the towns, to the villages for consumption, sometimes from as far away as 50 miles, which is quite the engineering feat, but also illustrates the value that even ancient civilizations found in bringing water into the villages for those necessities. The thing is that once the water is used, you have to take the sanitary waste away. It is critical for the health and safety of the inhabitants of villages years ago, and also now today just as critical for the inhabitants of buildings where we're bringing water in. And over the years, sort of the aqueducts have fallen out of favor. Nobody is really using those anymore, but folks have been manufacturing pipe and fittings for a really long time. Some, like the aqueducts, served ancient civilizations really well and worked during their period of time until advancements came along. You've had piping systems made of clay, of lead, of bronze, and of wood. Here's an example of one of my coworkers holding a piece of wood pipe. For those of you who've never seen it before, hollowed wood pipe that was wrapped with wrought iron, and you can see some spaces in between the iron and the pipe. Previously, when this product was manufactured and installed, it was coated with tar, so it was those annular spaces were filled in. But this served to bring water into villages and townships, as it were, to deliver potable water to folks for those sanitary needs. Now, obviously, we're not installing the leads or the bronze, the woods or the clay pipes much anymore, but a material that's been around really for a very long time, cast iron, is still widely used. Cast iron was originally invented by a German cannon maker in Germany in 1455. So the pipe and fitting system that we all know and love today, that's mostly referred to as MJ, also known as no hub pipe and fittings, was invented by a German cannon maker who didn't have much in the way of need for cannons. There were no conflicts. He wasn't selling many cannons, and he sort of was spitballing how he could make some money. And he used his cannon molds to make cast iron pipe. And the thing about cast iron, it has been around for a really, really long time. But in today's environment, some folks have noticed that there are applications that have become corrosive to cast iron and have been causing some breakdown. And that's sort of what happened with other materials, lead, bronze, clay, wood. Frequent deterioration sort of made them less appealing, and we don't want the same thing to happen with cast iron. What's interesting to note is that cast iron hasn't changed since that German cannon maker was making it in 1455 in terms of its chemical makeup. So why is it that now there are some applications that are corrosive to cast iron? Well, as you all know, things do change, and some of the applications have changed. We're in an age where people are clamoring for low flow fixtures. Since COVID came along, people are really keen to make sure that they're sanitizing things, whether it be in a restaurant, in a hospital environment, or even in a standard office building. The cleanliness of the building has changed. So there's a lot of aggressive cleaning chemicals that are going down the drain. And in a low flow fixture building, there's less water scouring the solids that are flowing through there. And some of the way that we've changed the applications that we're using cast iron and other materials have caused an environment that can be detrimental to many materials, not just cast iron. But the focus of this presentation is going to be on cast iron and what we can do to rectify it. But before we start, you take a look at some of these others that have sort of predated iron and have fallen to the wayside, like your lead and your wood. They're well documented cases of how those have deteriorated and become just sort of historic monuments to the way that folks did things before. Cast iron still has its place in our industry. It is still a very durable material, and specifying engineers are still happy to use it. But there are some questions about those aggressive applications and what the industry is doing about it. So we wanted to take you through a little presentation, give you a little bit of history, and tell you what the new and most cutting edge technologies are to help use cast iron in the applications that you've always used it in. But first, we wanted to highlight a few things that show the durability of iron. Here's a picture of the Palace of Versailles, which was installed in 1664. On that palace, cast iron, just like the cast iron that we use today for drain, waste, and vent, was installed as a pressure piping, and it was used for pressure piping from the early 1600s all the way up until about 1900. And then with the advent of sanitary standards for drinking water, cast iron sort of fell out of favor, and now it's not used to convey drinking water, but still used for sanitary use. But this cast iron pipe that's used in the Palace of Versailles is still in service after 362 years and still operating as it was to begin with. So it shows the versatility and also the durability of cast iron. Nowadays, we're not using it to pipe up pressure water to any fountains or anything else. We are still, however, using cast iron for sanitary drain, waste, and vent applications, storm drainage, and sewer. For these applications, most commonly in the Canadian market, you would use your no-hub pipe and fittings, which is most commonly referred to as MJ pipe and fittings for the mechanical joint couplings that connect the pipe and fitting systems. These can be used in above ground or below grade applications, and they're used all over the world for that. Most commonly, folks, if they're going to intermingle materials with cast iron, would use plastic underground for the ease of installation, and cast iron or plastic underground and cast iron above ground. The caveat is for cast iron, the temperature limitations are about 100 degrees C, which is really high. But for plastics, it's much lower, around 60 degrees C. For cast iron, also, it's designed and rated for gravity drainage. You have to have the sanitary patterns so that the water is essentially told where to go with the sanitary turns. And even though it's not meant for pressure applications, you should test your cast iron system to make sure that it is watertight to 10 foot ahead, which is roughly around 4.3 psi. So another sort of focal point that points to cast iron itself and how durable it is the Smithsonian Institute in Washington, D.C. And this is an advantage of cast iron over a lot of materials, is its longevity. So we're all familiar with the Smithsonian Institute. In 1881, construction was completed. In 2010, engineers and architects begun a renovation of the institute, and they did an evaluation of the cast iron pipe. It had been in service now for almost 130 years, and found that the pipe still met the specifications. So it was left intact. The original cast iron that was installed in 1881 is still in the Smithsonian. There's plenty of other case studies that would show the durability and longevity of cast iron. But there are other things that make cast iron a very attractive material. One of those is sustainability. Every piece of domestic cast iron that is manufactured in North America is manufactured from 96% post-consumer recycled scrap. And all cast iron is 100% recyclable. So in this day and age in North America, nearly everything that is made from cast iron was formerly some other form of cast iron, whether it be an engine block or a brake drum or a radiator heater, or maybe even cast iron soil pipe on a building that has been demolished. The other 4% of that equation that is not the 96% post-consumer recycle are just additives that have to go into the manufacturing process to keep the chemistry right, and also to process the material itself. So a little bit of shredded steel, some coke for heating and things like that. But all of the cast iron that is in the production of domestic cast iron or North American made cast iron is recycled cast iron. And the reason that I highlight the domestic or North American made is that offshore iron, that essentially iron that comes from China, they still use pig iron. So it is iron ore that is used to manufacture a percentage of their cast iron. But domestically in North America, it is all recycled cast iron. Now, manufacturers also in North America have ICCES verification that shows that their product is made domestically and is 100% recyclable, and that they use recycled content. And you can ask your domestic producers for that verification document from ICC. So Joining cast iron. There are essentially three different types of cast iron soil pipe that are commercially available. One is the MJ style, which we've mentioned multiple times, also again referred to as no hub. But another is service weight or hub and spigot. This hub and spigot style comes in a standard service weight or in an extra heavy. The extra heavy is most commonly used where you have a, a really large live load or an extraordinary earth load on the pipe, and you need that extra external pressure bearing capabilities. What comes to mind would be near railroad tracks, loading docks, or an airport is a great example of where extra heavy cast iron is used. So for your service weight and extra heavy, they're both hub and spigot styles. And Charlotte Pipe still manufactures both styles and have them in inventory. We're a manufacturer that manufactures all of our products for inventory. We do not manufacture for job specific orders. So everything that you see on in our catalogs, we have in inventory. But for joining your service weight or hub and spigot pipe and fitting systems, there are two separate joining methods. One is the old style that is a lead and oakum. So oakum is a burlap type material that is woven and wrapped around the spigot end of the connection and packed into the hub, and then molten lead is poured in on top of the oakum to hold the oakum in place. The oakum would expand when it comes in contact with water and is your vapor barrier. The lead just holds it in place, and there's a lead bead groove in the hub of your service or extra heavy pipe and fittings where that lead is poured in. Very few installers use that method anymore, with the exception of Chicago. The city of Chicago still requires lead and oakum service weight or extra heavy cast iron pipe in all of their commercial and industrial high-rise residential construction. So it is used heavily there, but in most of the world, it is used sparingly. Maybe if you have a historic project like the Smithsonian, where you want to keep the historical integrity of the building, you would use a service weight or extra heavy piping system. But advances in technology now have most folks who are installing those piping systems use a compression gasket. And you can see here the compression gasket that is used in the hub of the service weight pipe. And then you just essentially use a lead maul to knock it into place, or use a chain puller or some other type of device to get it into place. But essentially, the compression gasket is most commonly used these days. For MJ style, you have a no hub coupling, which uses a 3/16 stainless steel shield and a neoprene insert gasket. The neoprene gasket has a center stop so that you get equal coverage on both your pipe and your fittings when you're joining the pipe and fitting system. The stainless steel shield would slip over the gasket, and then it's tightened through worm gears on top. Now, here's an important note on MJ couplings. These are torque sensitive worm gears. And so a standard coupling uses 60 inch-pounds to tighten these worm gears down. For your heavy duty couplings, depending on the manufacturer, you've got different torque requirements. Most installers do not know that this is an issue that the manufacturers of the couplings need addressed. Most installers use your standard drill motor and tighten those things down and move on to it. But to get these things locked in place to the proper torque on a standard coupling, you should use a 60 inch-pound torque wrench. So you're going to place that gasket over the pipe and fitting in, pull your sleeve over, and then tighten it down. This is the most common way to install your your MJ couplings, and it's the most common piping system that's used with cast iron. Now, there are many manufacturers that manufacture tools for designed specifically for this task. Milwaukee Tool actually has a tool specifically for tightening down MJ couplings. It has a 60 inch pound torque setting, and it uses uh, a lithium ion battery so that there's no loss of power, that it just dies. So you've got a 60 inch pound, and then it can rotate to an 80 inch pound. Most commonly, manufacturers of heavy duty use 80 inch pounds coupling torque worm gears, but some have a 120. So you need to make sure that when you're specifying a heavy duty coupling that you include the installation instructions for that coupling. Also, unknown to most installing contractors is that there's a tightening sequence for the heavy duty couplings. These MJ style couplings, depending on the manufacturer, they could require a torque sequence that just goes from left to right or vice versa. But in some cases, we see an inside to outside. And this is critical so that there's no crumpling or bunching of the knurled stainless steel that you see on many of the bands, but also so that there's no bunching or a creation of a pathway for the neoprene gaskets. And again, most do not realize that the manufacturers have not only various tightening sequences, but also varying torque requirements for their couplings. Here you can see that there are several different couplings that are installed in this installation. As long as they meet the standard that is required for the coupling, there's no problem with intermingling these on an MJ pipe and fitting system. However, most coupling manufacturers have special colors that signify their trademark coupling. So in this instance, we had a contractor who reached out to us in particular and said, "Hey, I'm having some leaks on joining between pipe and fittings. Can you give me a couple of ideas of what it might be?" And so we went through the sort of the list, and I asked for a photo, and I've identified three separate coupling manufacturers in here, and with that, you have three different tightening sequences. You have two different hex head sizes for the worm gears, and you also had two separate torque requirements for these couplings. And so I asked the installing contractor what he was using to tighten these down, and he said a standard drive motor. So he was just using a drill. And once we sort of confirmed with him what the tightening sequences and the torque requirements were of the couplings, he had no more leaks. So this is important. If you could avoid intermixing the couplings, then you would only have one tightening sequence and one torque requirement from the manufacturer. But oftentimes, the contractors are going to use the material that they have on hand. They may use materials from different wholesalers, and you can get an application where you have an intermingling of different couplings. Now, again, the code requires that these couplings are manufactured to the same standard for use. And because of that, there should be no problem with using them as long as you understand the installation recommendations from each coupling manufacturer. Now, this sort of brings us to the coatings for the cast iron, because coatings are important when you're talking about both installation and longevity of the material, but maybe not always for the reasons that you think. Now, in the 1950s, a cast iron manufacturer from Europe brought his piping over to North America to try to sell it, because he had the capacity in his plants. And when installers saw his pipe, they were like, "Wow, this stuff really looks great." previous to seeing his material, the cast iron that you got most often had no coating on it. The coatings are almost always cosmetic. And what most in North America were doing was either no coating or just some standard asphalt coating. But this European manufacturer brought his coated material over, and because of the look of it, it incentivized the rest of the domestic manufacturers in North America to begin coating their product. Cast iron is a really durable material and has great corrosion resistance without the coatings. You think about manhole covers, park benches, even cannons that you see at some of our port cities in North America that have been out and weathered in the elements for hundreds of years. They stand up well to corrosion. Cast iron has free graphite in its structural matrix that helps inhibit the propagation of corrosion as well. But coatings do make the product look better, and in some instances, they really help with the propagation of corrosion. So, for most manufacturers in North America, they use varying degrees of coatings, two separate ones really for both the pipe and the fittings. So most fittings in North America come with an asphalt emulsion cold dip, which is 53% asphalt solids and then water. Most of the manufacturers in North America use this on their fittings. At Charlotte Pipe, we do not. We e-coat our fittings. So all of our fittings are electrostatically coated, where we do a 15 step process of beginning with a zinc phosphate pre-treat of the iron itself, and then we reverse polarity coat our cast iron fittings with an anodic and cathodic e-coat, which gives the fittings a much better appearance, but also better flow properties and corrosion resistance, because the molecular bond between the coating and the cast iron takes place and it adheres to the substrate. So there's no chance for delamination. There's no chance for dirty smudging of the asphalt or anything like that. Charlotte Pipe is the only manufacturer of cast iron pipe and fittings that uses that technology. But we have been doing that with all of our fittings now for 10 years. Now, on the pipe side of the business, 100% of manufacturers are using a hot dip asphalt. It's a petroleum asphalt, and it's used on the centrifugally cast pipe. It's essentially dunked into an asphalt bath, and that's what's used to cover cast iron pipe. Now, the reason that this is important, again, I said it at the beginning of our presentation, is that while standard cast iron is still appropriate for 95% of the applications that we've used it on for hundreds of years, there is 5% of the applications now that have become particularly aggressive towards not only cast iron, but other metallic piping systems. And it's because of the pH range of the fluids that are now being used or introduced into DWV and storm applications. What you would typically expect in a DWV system is going to be a pH range from about 4.3 to 10, really 8. But your standard cast iron can handle that range, actually all the way up to 10. And so your normal applications are well within the limitations of standard cast iron. Now, when these effluents and the pH limits of standard cast iron are exceeded, there are enhanced coated cast irons now. From Charlotte Pipe, we manufacture a product that's called Edge HP. The HP is for high performance, and it's a little bit of a play on the pH levels as well. So whereas normal cast iron can handle a pH range from 4.3 to 10, our enhanced coated cast iron can handle a pH range of 1 to 13. So on the pH scale is many, many orders of magnitude above what standard iron can handle. And this coating is an epoxy e-coat. So similarly to how we coat all of our standard fittings, we do a cathodic and anodic epoxy e-coat on our pipe and our fittings for Edge HP, both on the inside of the pipe and the exterior of the pipe, giving enhanced corrosion protection to both internal effluents that might cause corrosion and external any external threats that may come in contact with cast iron. So this chart gives you an idea from 1 to 13 of the sort of the fluids that enhanced coated cast iron from Charlotte Pipe can handle. And the thing that's important to note about this again is that both internally and externally, the Edge HP can handle these pH ranges, and you're not typically going to see lemon juice or tomato juice or sodas or even concentrated bleaches come in contact with the exterior of cast iron pipe. But what you may see are hot soils. You may see in parking garages the salts and chemicals that are used to treat the roads in icy conditions being brought in on vehicles. And this e-coat is very similar to the way that the underneath of your Chevy pickup is coated to protect it from the same sort of environmental corrosions. Now,
Just on the
model code, yes, sir. Do we
So
have a
before we go
question?
too far on in the pH scale there, I think the part that has really come up consistently is, of all the pictures that we had in the chart, uric acid is not listed there. Where does that typically fall in terms of pH, and how do those the various levels of pipe handle higher concentrations of, say, uric acid?
So here's an important thing to know about uric acid or any types of acids is that the code, and I was just about to get into this.
Oh,
The
perfect.
code requires special waste piping for applications where you're going to be conveying anything that cannot be discharged straight into the sanitary sewer, and uric acid would be included in that, or any acid. So while this piping system can handle pH ranges from 1 up to 13, it doesn't meet the standard for chemical and acid waste. And the code is very prescriptive in its language, requiring a special waste piping system for those applications. So I'm not exactly sure where it falls on the pH table, but what I would say is that if you're conveying uric acid or any types of acids or special or chemical waste, that you're going to have a piping that meets the National Plumbing Code of Canada for that application. Anything that has to be diluted before it goes into your storm drain is considered special waste. And this piping system, while it might be good for an application like that, doesn't meet those standards. One doesn't exist for standard cast iron, even if it is enhancedly coated. So where you might see aggressive chemicals, we'll get into that, where edge or any type of enhanced coated cast iron should be used is going to be outside of your special waste type applications. Does that make sense, Zach?
Yeah, absolutely. And I think one thing I'll comment on there, I guess two things actually. So it is a perfect tease. Thank you for leading me in. We are looking at setting up a deep dive into the world of various pipes and applications for them over the summer. One of which is going to dive into, again, neutralization and piping for, this type of chemical area. So we'll have that set up soon. If you're enjoying so far, please consider joining us again when we run similar presentations over, I think what the marketing team is calling like Pipe Month. We're just going to do piping for like an entire month. It's gonna be great.
Very
Um,
good.
But part of that as well is, getting to, and there was a comment brought up about glass piping. How does this relate? I guess do these coatings bring it to a level similar to, say, borosilicate glass type piping, or is that an nth degree more specialty than these enhanced coatings?
Yeah, so those are great questions. And again, I would just reiterate that the piping systems are different because of the standards that they're manufactured to and the requirements for the code. So for glass pipe, polypropylene, PVDF, even high silicon iron, which isn't manufactured anymore, but and then CPVC for chemical waste. There are essentially four commercially available piping systems for chemical or acid waste, or what the code would require or consider special waste. And this piping system does not fall into that category only because there is no standard that it currently exists that it could be tested to comply to. So while it might have the chemical resistive abilities on the pH scale, it doesn't meet a standard that is acknowledged by the code. And so for that reason, it can't be used.
Understood. And just while we're talking nuances in the code, when it comes to neutralization, for those that are joining us from the Canadian market, there is a bit of an open, a vagity to some of our neutralization requirements that I know they are working to try to firm up. Um, so in cases where you do have a neutralization tank, you may want one of those acid waste pipings conveying to it. And it sounds like this would be a great application for, say, low flow areas where we just have a higher amount of concentration, where maybe you are getting some pitting in various applications. We've had, some challenges, say, with water-free urinals where they're not getting enough dilution in terms of applications as you're considering this. Is that kind of fair to say?
Absolutely. Yeah, it's fair to say. Now, again, 95% of the applications are still great for standard cast iron. You would only use these enhanced coated materials where you've got some idea that there might be corrosion, or you've experienced corrosion in the past and you're wanting to replace it. But also, you probably would transition to and from your standard cast iron in outside of that area of corrosion. So this is, and I haven't mentioned it yet, this is the same dimensions, the same installation methods. The only difference is the coating for the material. So transitioning to and from standard cast iron it is no problem because dimensionally it's exactly the same. The coating is the only difference. The installation methods are the same, and the MJ coupling joining is exactly the same. But those specialty applications, again, for chemical and acid waste would have to be, you'd have to use the piping systems that are referenced by the code.
Perfect. Well, we'll let you continue on because I know I'm probably distracting you from wrapping up.
No, not at all. Thanks for the questions.
Perfect.
So this is essentially what I just mentioned, is that standard cast iron easily meets the needs of the vast majority of DWV installations. But you do have a lot of applications now that are getting high quantities of undiluted cleaning chemicals. Hospitals are one that comes to mind immediately, since again, COVID, hospitals are very worried about the spread of disease. And so also in these hospital applications, every fixture is a low flow fixture, and compounding the fact that the low flow fixtures are putting less water in to self scour these drains is that hospital personnel are seldom washing their hands anymore when they're coming in to treat patients, what you'll see if you've been unfortunate enough to have a loved one in the hospital recently is that a nurse or a doctor will come in and they'll take one or two pumps of hand sanitizer and they'll treat the patient, and then they take one or two pumps of hand sanitizer on the way out of the room, and very few people are putting the water down the drain in a meaningful way that is self-scouring the drains. Also, within hospitals, you've got commercial kitchens. And anywhere where there is a commercial kitchen, there is a chance for corrosion. And the reason for that is that now grease waste itself is not injurious to cast iron, but the sewer gases and the hydrogen sulfide gas that is created by solids being left behind, especially in commercial kitchens, can be extremely corrosive to metallics, all metallics. And so they're using aggressive cleaning chemicals. They're putting less water into the piping system. And in some cases, there is corrosion that is being caused by the solids from waste that is being left behind. I tell you, if you guys can point me to a commercial kitchen that is cleaning their waste traps out, as they're supposed to, it'll be the first one I've ever seen. And these grease wastes create an environment where solids are left behind. It creates microbes, and the off-gassing of this can be very corrosive. So commercial kitchens are one where these enhanced coated cast iron products have been specified with great success, and used with great success because they do have the ability to handle pH ranges, again, in many orders of magnitude above that of standard iron. Here you see that hydrogen sulfide gas has eaten away at the pipe at the top of this demonstration here, and the pH range of that corroded surface was measured at 2.85, so that it shows that it is below the pH threshold for standard iron, but well within the pH threshold of enhanced coated cast iron. And here you've got settled solids here under the waste stream from a commercial kitchen, where the pH range is 7.2. Now that's no problem to either standard iron or enhanced coated cast iron, but the wastewater is covering that up, so it's allowed to dissolve and penetrate the iron. So it's something to think about. Another application where you're getting really aggressive installations are casinos, resorts, and hotels because of, again, low flow fixtures, cleaning chemicals, the maintenance personnel flushing these chemicals down the drain without flushing it with water behind, the soda fountains and bar sinks that have really acidic fluids flowing into them. So what we would recommend is using, maybe an enhanced coated fitting or two, a P-trap, and a couple of links of pipe until downstream, until more water is introduced into the system to sort of flush that down and dilute it. And then you can switch right back to your standard iron. These aggressive applications, you think about the soda fountains, which I mentioned just a second ago. The pH range of soda is such that you can drop a 16 penny nail into a liter soda, and within a week it is totally dissolved. So quite aggressive. And most of us don't think about it, but the pH levels of juices is down around 1, 2, and 3, depending on the juice, which is very acidic and causes a lot of damage to metallic, which is why you'll see in commercial kitchens most of the material that's used on any surface area where they're prepping things is going to be stainless. And so if you've thought about an application that is particularly aggressive and using stainless steel for drainage, enhanced coated cast iron is your answer, and it's going to be much cheaper than stainless steel pipe. Parking garages is another really big one where engineers are starting to specify enhanced coated cast iron. And here you can see a length of our Edge HP that's been installed in a parking garage where the salts and chemicals from the roads have been able to come in and cause havoc on the traditional cast iron systems. Parking garages near salt water, where you've got a lot of salt air going through, have been really aggressive for metallic piping systems for a long time. These enhanced coated cast iron systems are really good in those applications. And here's just some internal corrosion that you see from those salts that are picked up on the road and the chemicals that are used from municipalities that are treating the roads. Also, some aggressive applications come from the soils. There are some hot soils where in the past you would think about possibly going to plastic, or if you're using standard iron, you would wrap it with a polyethylene wrap because the acidity level of the soils themselves. Here you can see they're replacing standard iron with our Edge HP in a trench where those hot soils have caused some corrosion. So in the past, where you're thinking about PVC Schedule 40 maybe as a replacement, but you're worried, and this in the last example, this was a pretty deep trench, as you can see. So they were worried about the loading on plastic pipe. Plastic, again, we manufacture both, so we're uniquely qualified to speak on it. But plastic pipe in and of itself is not very structurally strong, and it requires heavily on proper bedding, backfill, side compaction, of the earth for its structural strength. You can think about PVC much the same way as corrugated road culvert. It really needs the earth for its structural strength. And plastic pipe, many of you may not know, is considered to be in a failed state when it has deflected more than 5%. So it can be it's very critical that plastic pipe is buried to ASTM D2321. ASTM D2321 is the standard for thermoplastics burial underground for drain waste and vent applications. And it gives you the proper way to bury pipes so that you do not have a collapse of the pipe, and so that it doesn't deflect in a way where you get infiltration or exfiltration. So they chose to go with, in this deep trench, the cast iron with enhanced coatings for replacement of the pipe in that hot soils. Another reason why you may choose to go with iron over plastic pipe is that PVC and ABS pipe have a maximum working temperature of 60 degrees Celsius, where iron can handle 100. And this is especially critical if you start thinking about some of these aggressive applications like commercial kitchens. If you have dump pots for pasta, you're going to exceed the working capabilities. And even if it's dumping at, say, 130 degrees from a dishwasher, even at those high temperatures, the external pressure bearing capabilities of plastic pipe comes into the forefront at 60 degrees Celsius. PVC only retains 22% of its original strength. So you get things like this picture up here in the right, where the temperature has caused the pipe to lose its structural strength and it's starting to bow, or underground, the load becomes too much for the pipe to handle. So some have asked me recently, what about CPVC pipe? Because it can handle those hot temperatures like cast iron. CPVC can handle up to 104.4, so even above that of what cast iron can handle. The problem is that there is no CPVC pipe for standard DWV. We manufacture a CPVC pipe for chemical waste. It meets CSA B 181.3. but it does not meet the CSA 181.2, which is the standard for plastic DWV piping. It's really good with chemical resistance. It's very good with strong acids and bases. It can be used for your chemical waste along with polypropylenes or PVDFs or even the borosilicate glass that was mentioned earlier, but it's not listed for DWV. And CPVC, while it's great with chemicals, very good with acids and bases, it can be damaged by fats, oils, and greases. So you can't use it in commercial kitchens because the most naturally occurring oils actually stress corrosion cracking agents with CPVC. So you can look at manufacturers like Charlotte Pipe, George Fisher, or Spears, and they actually reference the chemical damage caused by fats, oils, and greases with CPVC pipe. Now, enhanced coated cast iron really is not new. You might be hearing about it for the first time, but Charlotte Pipe has had their Edge HP on the market now for 5 years, and others even longer. There is a standard for enhanced coatings that comes from Europe. It is EN 877. And ASTM is addressing this in North America. The EN 877 is a durability test standard for enhanced performing coatings, and essentially what it does is test the coatings for salt spray to make sure that it can handle those aggressive applications, for resistance to wastewater, and then chemical resistance all the way from 2 to 12. And what we have done at Charlotte Pipe is taken the requirements of EN 877 and incorporated it into the listing for our products, and we've doubled the test. So where EN 877 requires 350 hours salt spray, we test to 700. Where it's checking for resistance to wastewater at elevated temperatures for 30 days, we go double that. We've checked the chemical resistance all the way down from 1 to 13. So everything that EN 877 requires, we exceeded that with the testing of our Edge HP coating. But we're not the only ones. Sorry about that. We're not the only ones on the market. We're one of many who manufacture enhanced coated cast iron. Here in the top right, you'll see it an epoxy acrylic that is imported from China. And here you'll see the McWayne folks who own Bibby, Tyler, and ABNI manufacture a pipe called Dura. And it is also an epoxy coated. They epoxy coat the interior, but they manually coat the exterior. So there's some differences in the chemical resistance properties of theirs. But the offshore folks from China also adhere their coating in a different way. We are the only ones who use the E-coat, which makes sure that the coating is electrostatically adhered to the substrate so that there can be no delamination, and others have not used that technology. So because of that, there is ability for some of the others in the market to have delamination because the chemicals can or the aggressive effluents can get in between the iron and the coating itself, and cause corrosion. So just make sure that if you're if you're going to specify an enhanced coated cast iron, you understand which one and how it is adhered to the pipe. So delamination of the coating would be challenging for the overall health of the system. Also, because of the way some of these coatings are used, snaking the piping system out can be problematic. So again, I would just recommend that you do your due diligence if you're thinking about specifying an enhanced coated cast iron that's outside of the one that Charlotte manufactures in our Edge HP. So with the offshore, again, it's a two-part fusion bonding epoxy mixture that's sprayed on and then baked on for the fittings. And then with the pipe, it's sprayed on, air dried. Um, you also may want to ask for MSD sheets just to check the VOCs of the supplier of those pipe and fittings. Sometimes those VOCs exceed what is acceptable in North America. Now, for our process, again, it's a 15-step process where we electrostatically charge with both opposite electrons and neutrons the coating itself so that it does adhere to the substrate. There's a bit of a cross-molecular bond that's taking place with the iron and the coating so that there's no chance for delamination and that the coating is applied evenly to every part of the pipe and fitting surface. And we've sort of perfected this over the last 12 years with the e-coat process that we use for our fittings. Since all of our fittings have been e-coated for a really long time, our Edge HP employs similar technology. Here's just a photo of the pipe. You can readily identify the Edge HP of Charlotte pipe from its burnt orange color. And we did that so that we could delineate between our standard fittings, pipe and fittings with the standard color, so that no one would confuse the two and intermingle them if they didn't mean to. Another thing that we need to cover here is through all of the enhanced coated manufacturers of cast iron, they have different recommendations for cutting their pipe and fittings and then treating the cut ends. So the most common way, as you all know, for cutting MJ pipe is up through 6 inches snap cutters. Above that, most often folks are using an abrasive chop saw. No matter how you cut your pipe and fittings, you want to check with the manufacturer to make sure whether they recommend protecting those exposed metals from the cuts with the importers and the other North American manufacturers. They recommend that you do protect the cut ends because the way that they cut their cast iron, there is the potential for delamination if the fluids get in between the material and the coatings themselves. But with Charlotte pipe, we do not recommend that you protect those cut ends. They're already protected, and again, because of the e-coat, there's no way for the fluids to get in between the substrate and the coatings itself. And our e-coat is a low VOC, and as you know, most of the most of the green systems that are out there, like lead rating system from the USGBC, uh, they're very particular about low volatile organic chemicals. And the standards that we manufacture to, we use low VOCs in both our standard cast iron coatings and our Edge HP. So the standards require it and we meet it. So I got kind of quick there at the end of it, but I wanted to make sure that I left time for any questions if there were any. Just to reiterate, this is an ASPE accredited CU presentation, and you will receive continuing education credits for participating in this webinar today. Are there any questions from this presentation or anything that I may not have answered that you're interested in?
Nothing's coming in so far. I think first of all, thanks. That was fantastic. I really enjoyed seeing because I think cast iron pipe is so commonly just assumed to be equals equal equal, and not really understanding the different features that are available within a manufacturer and from manufacturer to manufacturer. So starting to understand how the different products play in the different applications was really interesting, especially getting into like which of the applications may have aggressive water. And There's a number of different applications where it is a joint answer. It's not just one product for the entire place. I do recognize we're already running a little long, so I appreciate everyone sticking around with us. I do just want to very quickly show how you might be able to find those different types of products and quickly add the right products for that right application. So if you are working on that commercial kitchen, how you could get your appropriately sized grease trap, which will certainly help with some of the effects, although they do need to maintain them. This ATS spec tool would help you select your scullery sink and the pre-rinse faucet and an appropriate trap that, as we learn, needs to be maintained. And then, of course, getting into the actual pipe itself, utilizing our templates and masters, which I'm going to take a little bit of time to explain here. But I promise I'm going to try to do this one 5 minutes because I recognize we're already a little bit over. First and foremost, ATS spec, as I mentioned at the top of the session, is a product selection, a product configuration tool. We have about 40 to 50 different manufacturers now. I think we're around 44, but the number's changing all the time. We're adding more and more manufacturers. I think we added two in Q1 already, and we're ongoing with additional ones for Q2 as well. So constantly adding new manufacturers to the system so that engineers, architects, interior designers, even design build contractors have the ability to specify more products from more manufacturers on the system. Unfortunately, parts of the feedback of that is like, one, we need to understand what the products are, and that's where this webinar recordings area is going to come in handy. If you would like to go back to the original training we did on Charlotte Pipe back in October, the recording will be here. If you want to understand how to size a grease trap or how to select that neutralization tank that we covered in the presentation today, there's recordings on those subjects as well. All of our webinar recordings from the last 5 years of ATS University are available here. And of course, if you have any questions on any of the product within the system, then certainly feel free to reach out to myself and my team, and we'll answer those questions for you. The important part to know, a couple of key parts to understand about the spec tool just on the outset. So one, it's paid for by our manufacturers. They are investing in keeping you, the designer or the specifier, up to date on their product knowledge and up to date on their models and their specifications. In the short version of this is it costs all the manufacturers substantially more money than you think to have out of date bad product data in the market. That is where ATS is living and trying to provide answers of how do we keep our specs up to date. I'm sure someone at your firm has likely done the January, oh, we need to update our master spec this year. February, oh, we're a couple, we're about halfway. We'll finish it up probably through March. March comes around and that project's fallen off because now we have real projects and real deadlines that we have to get done. This project needs to get out by the end of the week. This project's going for tender. Our goal is to help alleviate that strain. You can access your system as a firm, so you can share your projects, share your masters as a firm, and you can store your masters here. This will be a version that's similar to the one that you have in your internal file folder system at your office. However, by living on the spec tool, it's always up to date. So if Charlotte changes the Edge HP to the Edge BC after Brian, your master that has that product selection will receive a push notification. Hey, this model number has changed. We recommend you re-download your master. Or if the product gets discontinued, maybe there's a major issue and they change to the new Edge aggressive pipe. You would have a notification, hey, that product has been discontinued. Meet with us to help understand the new products that are available that will fill that void. Now, if we need to take that master into we need to deliver it to the market, whether in a quick selection or a full project, we can do so here in our quick action bar. A quick spec is as it sounds. It's when you just are looking for a single selection. We're doing a KFC or a fried chicken restaurant. We'll go non-branded, and we need to get a quick sink and trap and pipe to convey it all. Then we would just come in here, call it pipe, and this would help us select the pipe for that project. If we're doing the entire project where we need the sink, we need the trap, we need the pipe, we need the drain, we need et cetera, then you would come here for a project. You can see there's more information here. As we enter our location, we apply the local building code. So the Ontario building code, the BC building code, the Alberta building code, whichever one is appropriate. And this goes across the states as well. We would have by selecting the location, you ensure that you're being given the correct building code. So for example, if you're selecting Chicago, then we would have a rule that says, you need the service weight piping. And then the bid date allows us to keep it up to date. So if we go until October 10th, 2026, then the project is going to be kept up to date until the 10th of October as well. On the 11th, we stopped updating. That's the difference between a project and a master. A master is always up to date. A project is up to date until the specific date and has location that allows us to apply the building code. And then the basic level is our quick spec, which is just a title. So we could call this pipe and go right into the selection. When we're selecting, we've got all these different categories. Like I mentioned, we've been adding more and more manufacturers onto the system all the time. You can also filter down by application here. So we can search for Div 22 or Div 23. You can also filter by category. And we've also got your handy little pin where you can pin your favorite categories. So if we want to go in and select and start specifying our pipe, we could make our selections here. We can filter down by different ratings, pressure ratings, application type areas. You could filter by manufacturer. So if we want to see Charlotte pipes, we find their general cast iron pipe here. Hit, it tells us all the ratings that it has. Hit add product, and it would take us into what we call our fixture chain, where it's going to suggest the other necessary components. So your T's, hubs, and crosses. We can add our fittings in. And then it's suggesting, hangers and supports. It's suggesting those the no hub couplings, pipe identification as well. We can skip to the coupling, or we can hit complete and skip directly to our download. And then we could rename this pipe and then download the project selection here at the bottom. However, there's one other part. I mentioned the masters. One of the key reasons of using the system these days is to, one, keep your master up to date, and two, ensure your entire team is working off the same approved selections. So I'll use an example here. We have in this quick drawer, we have your masters, and then we have ATS templates, which is essentially ATS's masters that we've provided here as a means of improving your experience on the system. Your master would be like this Charlotte pipe master here, where we've got cast iron pipe, the edge pipe, CPVC, and PVC. Those might be the ones that are approved for your particular firm. Whereas the ATS template is a master that includes all the various products. So we've got, in this case, our supply pipe as well, copper and PEX. If your firm allows copper but not PEX, then you would just check the box and say yes. If you're doing general waste and aggressive waste for our casino project, then we would toggle that option. We need our pipe identification, the hangers, and we'll do a heavy duty coupling is maybe my firm's standard. So now I've checked those boxes. I can drag and drop directly into my system. And this works the same for your masters as well, the same functionality. We would pop open, select all products, and copy and paste over. Just drag and drop, nice and easy. So the key part is getting those masters set up. If you have not reviewed your pipe master in we'll say a couple of years to be as generous. It's been longer for a number of different engineering firms as well, I'm sure. If your pipe spec is a little bit more generic and you need to maybe ensure that we're getting something that meets all our certifications and ensures that it's appropriate for the application, then you can do so. We're happy to help set that up. That is what my team is here to do, is help set up those masters and then train your team on implementing that into your day-to-day. Lastly, once you're done, you'll download this in any of our different formats. We've got, submittals, schedules, 3 different types of written specs, the manufacturer spec sheet, Revit files for everything. And I always assume that I'm going to be a little bit late, so I pre-downloaded here. It just looks something like this. Gives you exact model name and number of what you've selected, the key important details. The manufacturer spec sheet, very similar, gives you a table of contents and then the manufacturer's details. In terms of written spec, everything, all of our formats are open and editable. So we could simply copy and paste this into your internal project book spec. However, you are issuing the spec to market. If you need a schedule, then we'd give you the schedule. But a little bit more detail, calls it the specific standards, but also calls out some important aspects of the product to ensure we're raising the bar a little bit. And you just get a nice zip folder here, something like this, that gives you all the different formats that you could then take from. So long spec, short spec, CSI 3-part spec, schedules, submittals, brochures, all those different formats. One of them is going to align with how your firm writes a spec and delivers it to the market. All of it is sponsored by our manufacturers so that you have better access to better data, better information, with the goal of improving accuracy in how it goes to market. An accurate spec on the front end leads to quicker and more accurate quotation on the back end, which leads to easier distribution for all of the manufacturers. So that's all the goal and how it all ties together. ATS is really just taking the data and trying to provide easier ways of accessing it and easier ways of keeping it up to date. So if you would like a more detailed version, please feel free to reach out to me. If you would like help in getting your master transferred onto the spec tool, which is, a tedious effort sometimes. And most importantly, if you've not looked at your pipe spec in a while, have a look and then shoot me a note, zach@atsspec.com, if you need help getting it updated. Brian and I will be happy to meet with you virtually, or I know he'll be coming to town at some point. So we'll, meet at your office if you're GTA or anywhere across the country, as he's living in a hotel, I'm sure. So feel free to reach out to us. We'll get you going. If you have any follow-up questions, just respond to our certificate of attendance email and we will loop that conversation into Brian. And otherwise, thank you all for your time. Enjoy the rest of the day. Great presentation, Brian. I'm looking for the next one during Pipe Month later on this summer.
Thank you very much, Zach.
All right, bye for now, all.
Bye bye.